In this question from JEST 2016, we are given that the maximum relativistic kinetic energy of beta particles from a radioactive nucleus is equal to the rest mass energy of the particle. So it is saying that kinetic energy is equal to rest mass energy m0 c square. Now, when a charged particle of charge E and velocity v moves perpendicular to a uniform magnetic field B, it experiences a centripetal force. This centripetal force is due to the Lorentz force. So Fc is equal to F Lorentz. Now, Lorentz force due to magnetic field is given by Lorentz force is equal to Q into V cross B. Now, if V and B are perpendicular, then it will be simply QVB, because sine 90 degree is 1. If we are interested only in magnitude, then Lorentz force will be equal to Q into V into B. Centripetal force is mv square by r is equal to Q is E, charge is E, into V into B. From here we can write mv is equal to EBR, or we can say P is equal to EBR. Let us name it equation 1. Now, momentum is equal to 1 by c under root k times k plus m0 c square. Here k is kinetic energy, m0 is rest mass. I hope you are already familiar with this equation of momentum. So when you put the value of kinetic energy is equal to m0 c square, it is equal to rest mass energy. Therefore, we have P is equal to 1 by c root of 2 m0 square c raised to 4. This is 1 by c. Or P is equal to 1 by c square m0 root 2, which is equal to root 2 m0 c. This is equation 2. Now, from equation 1 we have momentum is equal to EBR, and from equation 2 we have momentum is equal to root 2 m0 c. You should remember this formula. This is important in relativistic. In special theory of relativity, P is given by 1 by c into root of k into k plus m0 c square. Here k is kinetic energy. So from equation 1 and 2 we can write that EBR is equal to root 2 m0 c. From here we can say magnetic field is equal to root 2 m0 c divided by ER. Therefore, the correct option here is option B.